Okay, so in this video, again, we're continuing working through Unit 2, which is dynamics. So in this video, we're going to look at, start talking about friction. Okay, so the first friction that we're going to look at is kinetic friction. But let's first kind of talk about friction. So remember that no surface is going to be ever perfectly smooth. So prior to this video, we were making these assumptions that our surfaces are frictionless. Now, friction is a force that opposes the motion of a sliding object. So this is, right? So if the object is moving to the right, friction is going to act to the left, right? Because this is what causes objects to stop, or this is what you have to overcome to get objects to move and keep moving. Okay, so you have to push with, at minimum, the amount of friction. Okay, now friction, there's two types. In this video, we're going to discuss kinetic friction. Okay, so kinetic friction is the friction encountered when surfaces slide against one another. The main thing about kinetic friction is that the object is moving, right? And that's what the word kinetic means. It means motion. So in general, the force of friction is proportional to the normal force. And so we just say F sub K, right? In fact, a lot of times I like to use a lowercase f for friction. So let me go back and do that. So F sub K, that K signifies friction or kinetic friction, times mu K, and I'll discuss mu here in a minute, times the normal force. So mu K is something that is called the coefficient of friction, right? And basically it tells us, right, how slippery the surface is or how not slippery the surface is. Generally, it's between 0 and 1, where mu of 0 means frictionless. So you may see words like ice, smooth, right? These are all trigger words that says it's a frictionless surface. And then if it's if it's coefficient of friction closer to 1, it's usually lots of friction. Okay, it's very hard to move the object. Now, one thing to note is that most of the time, the normal force is going to be equal to the weight of the object, and you'll see when we go through our problem-solving process where this comes from. But remember, the normal force is not always equal to the weight, right? If you have other forces acting, you have to account for those. And so a couple things that friction does not depend on. One, it does not depend on the speed that's occurred between the surfaces. And the other thing is the area of contact between the surface. So if I have wood, right, and I kind of slide that same block on, right, in both ways, my coefficient of friction or my friction is the same thing. What matters is what the surfaces are. Wood on table, wood on wood, sandpaper on sandpaper, wood on ice, wood on wet road, wood on dry road. Okay, so it's not those factors, it's not the speed, and it's not the area. Okay, it's simply what the surfaces are. Okay, so let's look at an example problem. So this talks about a salt shaker. Okay, so someone at the other end of the table asks you to pass the salt. Feeling quite dashed, you slide the shaker with a mass of 50 grams in that direction. The shaker slides with an acceleration of 0.787 meters per second squared and comes to rest at the desired location. What is the coefficient of friction between the shaker and the table? So here's my salt shaker. Okay, so I have my two standard forces in my draw step, right? Again, draw, sum, solve, right? So draw the free body diagram. Now, this is one in which it's sliding, right? So we have no applied force. It's not like we're constantly pushing it. We're just sliding it and it's going to move on its own. So the only force that's acting is friction, okay, in the horizontal direction. So this would be like if we're in a car and we jam on the brakes, right, the old school drum brakes, and we're like, right? So the only thing in that case is like we're kind of at the mercy of the road and the tires, okay? And so the only force we have acting is friction. Okay, so now we do our sum step. So I'm going to sum the forces in both directions. And so I'm going to say the sum of the forces in the y direction, or the net force in the y direction, is equal to 0. It's not accelerating up or down. And so the two forces I have acting are normal force and weight. And so here's a case where our normal force does equal our weight. Okay, so I got Fn equals Fg minus, or excuse me, but Fg equals mg. And so now I have the sum of the forces in the x direction. Now the reason why we do this is because we need the normal force, right? Because remember, the equation for friction is mu times Fn. So we need that normal force. And so the sum of the forces is going to be m times a, because we are given an acceleration. So we know it's going to be equal to m times a. And so the only thing we have acting is negative friction. All right, and so I'm going to plug in my equation for friction. So it's mu sub k, right, times Fn equals mass times acceleration. But I found that normal force is equal to mg. So I'm going to say mu k mg equals ma. I forgot my negative signs. So notice that the mass goes away. And then with this equation, negative mu a equals negative mu kg, right? And so this is the acceleration of a sliding object on a horizontal surface. Okay, once we start introducing angles and inclined planes here in a couple videos, then we're gonna that's not gonna hold true. We're gonna have other factors here. Okay, so now I'm looking for the coefficient of friction. So I'm gonna solve this for mu k by simply dividing a over g. Now, this is coming to a stop, so my acceleration is going to be negative. Okay, and then I'm going to divide by 9.81. And so my coefficient of friction between the salt shaker, which is glass, and the table is 0.082. So that's very close to 0, right? Just slightly bigger than 0, which means that this table glass interaction was nearly frictionless. Okay. Now this could be part of a dynamics question or a waterline question, which you'll see here towards the end of this unit, where you can work backwards. You can be given this, then you use this to find the acceleration, and then you use something to find like how far did it slide, how long did it take, okay, what was the initial velocity of the salt shaker. Okay, but there's all these things that you can find, but a lot of times it'll start right here with friction. Okay, now in the next video we're going to look at the other type of friction, which is